Hi everyone, welcome to my channel. In this video, we'll be talking about the RHESSI satellite used to study the sun's solar flares. Please remember to like and subscribe. Now let's get right into it. Fact 1. A long acronym. It is probably not a secret to you that RHESSI is a huge acronym. The satellite actually is named the Reuven Ramaty High Energy Solar Spectroscopic Imager. No one can really say that fast, and therefore they shortened it to just RHESSI, and this is the name that's known for the past 20 years. The RHESSI satellite was launched primarily to study the sun's solar flares. And the first two acronyms, Reuven Ramaty, is actually a Hungarian scientist that was known for the work in this field, and therefore the satellite was named after him. The satellite is composed of many different imaging systems, sensors, and cameras. And so the long name encompasses everything that it's supposed to do in order to advance the study of solar flares and how they impact the Earth's atmosphere and also the electronics that are on Earth. Alright, let's get into the next fact. Fact 2. Control from Berkeley. The satellite's primary ground control station is actually in the San Francisco Bay Area, in the Berkeley, California hills. In the California Berkeley hills, there's a space laboratory that is affiliated with the University of California, Berkeley. This is where scientists are based in order to control and receive the data from the satellite. The Space Science Laboratory at the University of California, Berkeley is where all the scientists gather in order to control this satellite. The ground control station is in the Berkeley Hills, and from there, the scientists could point the satellite at the right angles to the sun so that they can study the solar flares that are ejecting out of the sun. This is also where they receive all the telemetry data, camera data, sensor data, and spectrometer data in order to further their study and add to the research data to the sun's solar flares and its impacts. Of course, Berkeley was not the only ground station, although it was the main one. There exist several other backup ground control stations because, as you know, the satellites orbiting around the Earth at a frequently high speed, and sometimes perhaps it is at the wrong side of the Earth in order to be controlled from Berkeley, and so they would need backup ground stations. The backup ground stations are in Virginia, Germany, or Chile. Alright, let's get into the next fact. Fact 3. Study of solar flares. As I mentioned in the previous section, the sole purpose of this satellite program and its mission was to study the solar flares and its impact to the Earth. Of course, as you know, the sun is very bright and packs so much energy. So a lot of the studies of this satellite is actually done at the X-ray level. It captures a significant amount of X-ray images and sensor data in order to study the solar flares. The researchers believe that much of the energy released during the flare is to accelerate high energy electrons, primarily X-rays, and protons and other ions. The approach of the RHESSI mission was to combine high-resolution imaging with hard X-rays and gamma rays with high-resolution spectroscopy so that the energy spectrum could be obtained at the point of the image. The RHESSI primary objective is to understand the processes that take place in magnetized plasma of the solar atmosphere during the flare. It measures the impulsive energy release, the particle acceleration, and the particle energy transport that are induced by solar flares. Scientists are especially curious on how the particles and protons from the solar flare impacts the Earth. Alright, let's get into the next fact. Fact 4. Circular orbit at 600 kilometers. Even though the RHESSI satellite is used to study the sun, it is not necessarily close to the sun. In fact, it never left the Earth's orbit. Since its launch in 2002, over 20 years ago now at the time of this video, the RHESSI satellite has always stayed in a circular orbit above the Earth at 600 kilometers. It continuously orbits the Earth in a circular pattern, and as I mentioned in the previous section, controlled by our ground station to adjust and point it in the right direction toward the sun. This is very different from other types of satellites, where it's usually sent toward the celestial body it's trying to study. For example, when we try to study the Martian planet, we send satellites to orbit the Mars. Also, same with Venus, and so forth. However, the RHESSI satellite has always stayed close to the Earth and is able to transmit images from the sun back to the Earth ground and did not really have to venture out into outer space. The RHESSI satellite likely used the same geostationary orbit that other satellites use, which means that it's usually hovering over Earth at the same spot as it orbits around the planet. Alright, cool. Alright, let's get into the next and final fact. Launched via Pegasus XL. When we think about satellites, we think of launching them into space using heavy rockets, such as something you see here. However, this is not actually how the RHESSI satellite was launched. In fact, it may really surprise you that the RHESSI satellite did not use a heavy rocket with boosters to launch it into space. No, it used the Pegasus XL system. And this system is incredibly interesting. What happens is, first, the satellite is loaded into the Pegasus XL rocket system, which is what you see here, and it's attached as like a missile for a plane. The plane is not usually a fighter jet. The plane is usually a cargo jet or scientific large airplane, such as the orbital science airplane that you see here. The airplane takes the Pegasus XL up to a high altitude and releases it. Once released, the Pegasus XL, because it's already at a high altitude, is able to ignite and accelerate toward space and launch the object or payload into the orbit. Of course, this type of satellite launch can only be used for small satellites. You can't really launch large things with this method. Alright, that's it for my video today. Thank you so much for watching. Please remember to like and subscribe. See you next time.